Alright, in this lesson we'll have more shortcuts for sketching these graphs. And this is an accent, like an upside down question mark. It makes the C sound like an S, and this is called a limacon. A limacon could look like this. Or like that. And when we look at the graph of cosine, it will be symmetrical to the polar axis, and this will be symmetrical to pi over 2. Now, if we have absolute value of A equals absolute value of B, it doesn't matter if they're negative or not, then we would get a graph like this. It's going to go back to the pole and out like that. And that's a limacon. It has, this is A plus B, this is A, and that is A, or absolute value of A. We don't care about this sign. All right. If we have sine theta, it'll just go this way, where that is A, that is A. Let's just say the distance A, I guess it's, we say the radius is A. And that is A plus B. If B is larger than A, so we have this being larger, that's going to make a loop on the inside. The loop will be the size of the difference of A and B. So we'll have the same shape. We're going to go out to A plus B is out here. We'll go to A here, back to the center. But there's a loop on the inside, and that loop has a length that's equal to the difference of A and B. Okay, if A is larger than B, then there won't be a loop, it'll go the other direction. So we still have going out A plus B, that'll be A, but now instead of going the difference of A and B this way, we'll go the difference of A and B this way. And depending on how far out it goes, there might be a little dimple there, or maybe it'll just be straight. So we go out A in both directions. Okay, so we have this number is larger, that means there's going to be a loop. Cosine means it's going to be symmetric to the polar axis. The loop will be the difference of these in absolute value, which is, it'll be 3. But what about that negative? What's it going to do? Are we going to have the graph go on the opposite side? So let's just look at the maximum radius is going to be -1 plus we want this to be -1. If cosine's -1, that will give us the maximum radius. If I put a +1 there, then we won't get 5, we'll get 3. So that's how we get the maximum radius. So we want cosine to be -1, and that means theta is pi. So we're going to, when we go to pi, we'll have a radius of -5. All right. So if we go to pi, we'll have a radius of -5. So we're going to start here, even though we have a negative there. It all worked out to put us at the same place. Now 1 is going to be these points, and it's going to give us those points. And we also have a loop of size 3, so that'll come out here. And if we go like that, we'll have a loop, and then back through. All right, pause the video and try the next one. So here, a maximum radius occurs when cosine is 1, and cosine equals 1 when theta equals 0. Maximum radius is 5. We'll have a radius of 5 at 0. And we'll also go to 2 on that axis, on that line. There will be a loop of size 1. So we have these, and a graph like that. All right, let's look for the maximum radius. That's going to be 3 minus. So what number goes there to make us have the largest number here? If I put a 1, then we'll have 3 minus 2 is 1. But if we put a -1, it'll be 3 plus 2 is 5. So this tells us that we need cosine to equal -1, and that happens at pi. So we're going to rotate to pi and have a radius of 5. And when we rotate to 5, we have a positive radius, so that means we do stay there. We don't flip back, reflect the other way. 3 tells us 1, 2, 3. We have a point there. And the difference of these tells us, no, there'll be here. We don't have a loop because this number is larger, so there's no loop. It goes beyond the pole. So it'll come out here. All right, pause the video and try this one. So we'll have the largest radius when cosine equals 1. Cosine theta equals 1 when theta equals 0. This is larger, so there won't be a loop. It has a maximum radius at 0, and cosine tells us that we have it's symmetric to the polar axis. So 5, at 0 we go 5. And 4 on the other line. We don't have a loop, and the difference between 4 and 1 is 3. So that means we'll go all the way out to 3 here. We'll go through these points. So now we have A and B are equal, so the graph won't have a loop, but it'll go right to the pole. Now let's look for the maximum radius is going to be 5 plus 5. If I put a 1 there, that means we get the maximum radius. So we want to know, when does sine equal 1? And that happens at pi over 2. So at pi over 2, we have a radius of 10. We have points on the polar axis at 5. And because we have 5 and 5 being equal, then we're just going to have a point there. Okay, pause the video and try that one. What number do we put here to get the maximum radius? Well, the maximum is going to be 6. We would have to put a negative 1 there. So we need to know when sine is negative 1, and that is when theta is 3 pi over 2. Three pi over 2. At 3 pi over 2, we'll have a radius of 6. We'll also have points on the polar axis at 3, radius of 3. Since these are equal, they're equal, so there will be no loop. We have points here, and get a graph like that. And the rest are pretty simple graphs, not much variation. Here's a polar equation. Let's just do these. The radius is always 3. Well, that's going to make a circle. So we won't bother practicing that. Then theta. Let's look at if we have theta and r 0. Let's try pi over 4, pi over 2, 3 pi over 4. And we can just estimate what the radius is going to be. Well, it's going to be 0 there. The radius is pi over 4. I guess we don't have to estimate, but in order to graph, we should estimate. All right, let's go to 3. And we're looking at pi over 4. All right, at 0, we have a point at 0. We have a radius of 0. At pi over 4, we're going to go a radius of pi over 4, but let's estimate that to be 3 over 4. So at pi over 4, we're at 3 over 4. At pi over 2, we're at 3 over 2. Well, there's 1. There's 1.5. So we're going like that. At 3 pi over 4, this is going to be more than 9 over 4. So it's more than 2 1/4. So we're going to go out to there. At pi, it'll be on 3. So we can see that it makes a spiral. And this will also be a spiral. It'll just be a little tighter. So let's look at theta and r. 0. We're just going to divide this by 2. Divide by 2. Divide by 2. And 0, 0. And then we're going to go, this is 3/8. So at pi over 4 will be around a half. Here we have 3 over 4. At pi over 2 we're at 3/4. And this will be 12 over 8. So that's going to be 1.5 approximately. At 3 pi over 4 we go to about 1.5. And at pi we're at 3/2. Something's off there. This is 12. No, this is 9 over 8. So we're not at 1.5 here. 9 over 8 will be closer to there. And now we're at 1.5 at pi. So we see it going like that. At 3 pi over 2, that would be 3 pi over 4. At 3 pi over 2, the radius is 3 pi over 4, and now we have 12 over 4. That's about 3, a little more than 3. No, sorry, 9 over 4, so that's going to be a little more than 2. And we get a spiral. Okay, and the last ones, the sketches are, we're not going to do much variation to the sketches, or to the types of equations. These are called lemniscates. So they will be symmetric to the line pi over 4. We have a radius of 3. And then we just have that shape. So pause the video and try this one. Still has the same symmetry. And the form of the equation always has to have 2 theta and an r squared. And this is just what changes here. When we have cosine, it'll be symmetric to the polar axis and with a radius of 2. So pause the video and try that one. We have a radius of 3 and it's symmetric to the polar axis. And we'll stop there.